Recording is started now. Yeah, recording is started. So we were discussing about like linked list. So linked list is what? Basically, it's almost similar like array list, but it's a implementation wise it's bit different. If you go to this one, the collections diagram, you can see here linked list. So DQ is also the parent of there and list interface is also the parent. The first difference you will find here array list and linked list, because this is a very important interview question, that what is the difference between array list and linked list. So first thing you can tell that array list is having like parent as list interface, but linked list is having like list and DQ. So this is double indent queue and which is coming from the queue interface. So basically it provides a doubly linked list kind of a structure. It's create the address of previous and next node. And basically it's a dynamic like a node creation things. So one place it is kept for value, one place it is kept for previous, and one place it is keeping for next. So in this way it is maintaining the addresses of the what you call it, the nodes. Basically how to explain you, like let me show you some kind of diagram. MS Paint. So basically what it happens when the first node is created, it is like creating like this. Let me take this diagram. So this is called a node, okay? And second node is also created when you are creating the next one. So what it does, it creates a new node like this, and then it is creating a new node like this, then it is creating a new node like this, then it is creating a new node like this. So in the array list, basically the capacity was decided once the first element was added. But in the terms of linked list, it is not like that. Capacity is as equal to the size of the linked list. Basically, it's 100% dynamic thing, and insertion and deletion in between is very easy. Suppose that, consider one example. This node has to be come here, okay? So what it will do, it will just update the address. This will start pointing to the this element, okay? And one thing it will create the address of the next, and one thing it's create the address of the previous. So when it is the first node, what it is doing, it is like this kind of a structure. First node is keeping the previous as a null, so it is having a previous, and this is called a next, okay? So next will point to the next element and previous will point to the previous element. Once it is like first element, the previous will be null, and when it is a last element, so next will be null. Suppose that this is the last element, okay? So what it will do, it will design like this. So this one is previous. Let me write here previous, and this is the next. So if it is the last one, so next will be null. Means it will point to the null one. Next will point to the null. NU double L, null. And in the case of first one, it will point to the null. This before this, there is nothing like that. And what are the middle positions are? Middle positions is for value. In every node, it will create previous, next, and middle position is for value. So it will keep a value. So if I go there and write like V, then you understand V is for value. Here also V is for value. Here also, like if it is a middle position, the middle position is for value. So just imagine, and the left side is for previous and the right side is for next. So what it will do, suppose that this is the second one and this is the third one. So it will point like this. Consider that this is something next one, right? This is next. So it will point to the previous of the next. Okay. and this will point, suppose that this is the third one, this is the fourth one. So what it will do, this next will point to the previous. So basically in this way node creation is done and it is storing the address of that. I'll show you if the diagram supports, then I can show you. You can see a linked list. So first is null, then it is going like this. The element is being stored, and from any node you can come first and you can go to the last one. And if it is a last, then it is a tail. So tail is pointing to the null. Okay. And if it is a head, head is pointing to the null. So before that nothing is there, and after in the tail there is nothing like that. So in this way the data is stored. I will show you practically, then it will be very more useful for you. So basically in the interview, they will ask that why you are selecting or why you are going for linked list or why you are going for array list. So you can tell that based on the operations, like what kind of operation I have to perform. I will select the array list or linked list. So consider that you have to keep on insertion and deletion a lot. So insertion and deletion is lot, then you can go with the linked list, because in the linked list insertion and deletion is very easy to maintain. It's just an insertion of node and deletion of the node, and rest of the things like memory management is nothing. It is just automatically managed. But in the case of array list, if you have to insert in between and delete in between, so what it will do, it will shift the entire data, and there comes the memory management. So this is better complex kind of things in the array list. So you can tell that based on the operations, means what kind of operations I have to perform. Then I will select my data as array list or linked list. So array list is like what you call dynamic array, and which grows and shrinks based on the like insertion and deletion of the data. But insertion and deletion, if it is at the last position, so array list is like a good option, you can go for that. But if the insertion and deletion is in the middle, then it is a difficult thing, like it would be a more time consuming thing, you can say. And for like a computer also, a memory management thing also, like it's required a lot of statistics. Consider that you have 1 lakh data or millions of data you have, and suppose that you have to delete something from the in between. So what it will do, so once you deleted something, the entire data has to be shifted into the left position. Once you are inserting something, then entire data has to shift to the right position. So insertion and deletion, it bit complex in the case of array list, only if you have to insert and delete in between. But if you are inserting and deleting at the last of the position, then array list is a good option. But in the case of linked list, insertion and deletion in between is very easy to manage. So that's the main thing. Now second point is traversal. So like insertion and deletion you have already seen. Now comes the traversal. So traversal is, suppose that we have to find some data. So in the case of array list, we have random access, provide random access. Okay, you can go and check the random access and you can just go and print it. But then in the case of linked list, consider that you have 1 lakh or millions of data you have, and now what you have to do, you have to print the last one. So what it will do, it will start from the first node, then check to the, like if it is found, then it will not found, then it will go to the next one, then it will go to the next one. So it will keep checking everything. Okay. So in the based on operations, suppose that you can tell that what operations I have to do. Suppose that I have to provide like kind of printing data. So printing like random order I have to print. Then the array list would be good option. But in the case of linked list, every time I have to start from the first position and then go to the last position. So in this case, the linked list is not good option for traversal, because based on data size, it has to always start from the first position and traverse to the particular desired position. So these are like high level things, means kind of interview of answers. But you see what are the other things it is saying about that? Implement the list as an array. So basically it's the array implementation, a dynamic array. Implements doubly linked list. Okay. So it is a doubly linked list, what you call arrangement, where data is there Header is there and next is there. Means it is just pointing the previous and next. It provides random access, no random access, need to traverse, access the ith element. That's whatever the element you want to find, you have to traverse from the starting to the data element. Insertion and deletion required shifting. Okay. So this is something, if it is in between, then required shifting. But if it is at last, then it's a good option, array list. Insertion and deletion is easy to maintain, no shifting required. The most important thing about what you call linked list. Need to be resized when out of a space. So what it does, it automatically grows and shrink. I already told you. This demo you have already seen, right? But here, no, nothing like that. Only memory is allocated and necessary action is taken. So insertion and deletion is very easy. Like no need to maintain anything like that. So based on the operations, you can think of that what you want to select, either array list or linked list. Okay. So these are theoretical example, but practically I would like to show you more. So linked list. So basically, what is the definition of linked list? Linked list is there, which extends abstract sequential list, implements list and DQ. This is the most important thing we have to understand. And the clonable and serializable are already there. And this some of the high level points they have mentioned. So duplicates is allowed, like list all the classes, duplicates allowed. Insertion and order is maintained. It is non-synchronized, means faster in execution. Manipulation is fast because no shifting needs to occur. The manipulation means like inside data or in between data or deletion or insertion is easy. So there are a couple of things they have highlighted. This is the basically doubly linked list structure. You already see that. Head no, head node. This is the first one. It will head will point to the null, but the next will point to the previous of the next element. Okay, PREV of the next element. And then it is this B. This is node B. So node B next it pointing to the C, and C previous is pointing to the this one. So this is called the doubly linked list structure. Basically, you don't need to create it. You just have to use it. But for using also, you have to understand the logic behind it. So this is something diagrammatically shown here, which you can understand. Pointer to the previous node, content of the element, pointer to the next node. So basically, a node can have three things. One is pointer to the previous one, pointer to the next one, and inside the middle one is the element, the value, which you will send it to store like this. And this is single linked list structure, means we are not using it. Basically, this is just a diagram, what you call explanation they have given. Content is there and pointer to the next node is there. So simple like simply list is. Now we will see the methods and everything are almost same. Linked list. You can see it. So linked list is there. You can pass the collections to create also. The particular constructor is there. Two constructor they have given. Add method is there. Add all method is there. Almost same. Clear is there. Clone is there. Contents is there. So descending iterator is there. Element is there. Get is there. Get first is there. Get last is there. Some additional methods I am seeing here in the array list. I think these were not there, right? Get first, get last is kind of thing. Linked list has some additional method. Peak is there, peak first is there, peak last is there, Paul is there, Paul first, Paul last. So basically these methods are the methods from the queue. Okay. So that's why it is present here. I will try to show you a couple of things. Remove is there, and remove is there. Three remove are there. One is like just remove. One is index based removing and one is object based removing. This is remove first occurrence. If it is multiple, then remove first occurrence. Remove last, set is there, means update method is there, size is there, two array is there, split data is there. We are not using a split data. Two array we are using, so I will show you a couple of demos about that. So let's go there, the demo section. Linked list demo. You can see here how we are creating your linked list. The line number 11. So data type is, you can define here which kind of data. You want to pass linked list, whatever you want name, that should be okay. This is the linked list and the data type, which kind of data I'm going to hold, and this is the constructor. So in the linked list, you have seen that we are having two kind of constructor. One is blank one, no parameters, and one is collections you can pass. So we have the first demo about the constructors and what you can. It's same like array list, it's like just. But I will show you when I will execute it in the debug mode. That would be better. So initial is, I'm printing the initial one. Then you will see the value is nothing. When I'm adding some of the elements and then I'm trying to print, then you will see all the things. And random access is not there, but index with get method is there, which you can use for printing them. So this is allowed. Let me comment this part as of now or to temporary. Now let me show you that this is the name AL I have taken. So first when I am printing here, it is printing nothing. And when I am printing with after adding the value, then you can see it will print something. Run as Java application. So you can see here first it was blank one. Okay. So if this symbol is coming, you can understand it's a blank list or array list. So list, array list, or like linked list, whatever it is. And then it is printing the sum of the orders. You can see here what I have added. I have used add, and here I have used add first. So add first is what? So it is mean to say that I want to add it as the first position. So that's why it is printing like that. You can see here. So when I'm adding 21 number line, Ajay 1, 2, 3, and when I'm printing, you can see it is coming at the first position. Now let me show you this program in the debug mode. From here, right click, toggle. I have toggled this line number 11 and then I am going to run it and the debug mode. You can see here, this is variable section. As of now, there is no variables and it's a blank one and I'm going to start my program. Step over. So once I did that, the name was AL. So it created the reference as AL. And then what it did, it has first, last, mode count and size. So when it is printing the first one, that is okay. There is nothing. There is nothing. And when it is trying to add the first one, then you have to keep noticing here what is the thing it is going over. It added the first one. And when I'm going here, size is 1. Okay. And you can see here, since it is the first node is created. You can see here. So it has item is what? Ravi. The next is null. The previous is null. Okay. And one we have like a reference which will point to the first. So first is what? Head. and last is the tail. Okay. So we have couple of things to notice. We have a first, we have a last, and every item, every node element will create a node, and node will have item, next, and previous. So in the terms of item, you can see how the value is stored in the forms of array. Value is string. This is a string data, so it is stored in the forms of array. And now we have a next and we have a previous. So next and previous as of now are pointing to the null because this is only the first one, right? So let me add one more. So once I added, it means Bizai is added. So now come here and see again. So last is what? You can see last is Bizai. First thing, first one is Rabi and last is Bizai because I have just added two elements, right? And once I go there in the first one, you can see here which one I'm pointing, the first one. Okay. So it was Ravi. Vijay come first. No, it is Ravi, right? Okay. Ravi is there. And the next is pointing to this one. That is correct. Okay, okay. I got confused. The next is pointing to the Vijay. You can see after Ravi, it is pointing to the Vijay. And Vijay, when you come to the last one, then you see here, it will point to the first one. Item previous. You can see previous, which one it is pointing. It is pointing to the Ravi. So it is like having two references. One is for the previous one and one is for the next one. So in this way, it is internally managing the things you can see here. And there is no initial size, and after addition, there is no size like that you can see. Every time adding, then it is just increasing. So linked list has by default size of 0. And once you add the element, then it will keep on growing. So you can see here, now the last is changed. Earlier it was having like, again it is pointing to the Ravi because it's a duplicate element. Next time I will correct it. Let me here as a 111. Ravi Vijay. Debug as Java application. So here we have seen Vijay we have added. Okay. So after adding the Vijay, you see here what happened here. So now we have two elements. So when we have two elements, then with the first and last is updated. In the first, it is having Ravi, and in the last, it is having Vijay. But you go to the previous and next, then you will understand. So next is pointing to the null because after second, there is no element. But next, this is pointing to the previous Ravi one. The second element, previous is pointing to the Ravi. And the first element, previous is pointing to the null, you can see here. But the next is pointing to the Vijay. So in this way, it is maintaining the node structure. And one more important thing I will show you, which is very interesting. Let me complete this part. Once you add the null, so null is also added, and you can see here how many items. The first and last is an additional thing, but like it will keep storing all the items. So now when I'm going to printing here, it's printed. You can see everything is printed. Then I'm finishing it, and then I'm coming to the Java program. So now I'm going to one more important concept with you. Go to the linked list. Okay. And then you will see how it is being stored. So I'm inside the linked list class, and then I'm going with the show view outline. So I want to show you the structure of data, like how it is created. You can see here line number 94. The first is like this, and it is having a node structure. So whatever it is node, you go there node, Node is inside the linked list. So node is a class inside the linked list. You can see here, private static class node. So this is the inner class. So class inside class. If you look carefully, then you will understand because it's written so down now. That's why. Linked list. Yeah, this one. You can see or not? I have turned the green one. So let me turn off. Then you can see here. So you can see here, linked list is having three additional classes. One is descendant iterator, one is list iterator, and LLS splitter, and one is node. So once you come to the node one, you can see this is a private class. So color wise, you can see this is a red color, and C is for class, and S is for static. So it's a private static inner class, class inside that. You can see here. So this is the outer class, this is the inner class. And what is inside that? The structure. That whatever the data type, suppose you are taking a string, so it will become the string item. Then it will become the string next, string previous, like kind of this will, based on data, it will be created. And it has a constructor. What it is doing here, it is having three things. One is data, you give me the data, you give me the previous, and you give me the next. So based on that, it is internally creating. You don't need to go through that, but you just need to understand that how it is internally managed. So linked list is internally managed by the node class, and node is a like data type which is having three things. One is item, one is next, and one is previous. So based on that, it is managing everything. Okay. So this is just a very interesting fact about node class, and it is being introduced in the collections only when you will deal with the link. So whenever you see the link now word, then you understand this is just managed by the node. Otherwise, it is not possible to manage. So whenever there is a concept of node, so you can just recall of this concept, what I have explained. So this diagram will be created and internally it will be managed. So you don't need to go into that how it is being managed. But yeah, at least high level concept you should have, that what kind of node structure you are going to create and then how it is managed data. Now coming back to the linked list demo. You can see here in this way it was created and it was just printed over there. So this was one example. Now we have some methods in the linked list class. So I'm going to the linked list. You can see here we have some methods called get. Get method was there where you can have two things. One is get first, one is get last. So three methods they have given, and based on that you can use three methods to print. So let me go there and see if we can show you. One is get via indexing. I'm going to print it, and I'm expecting that it will print the data, the first one. Because get of index 0, it means just the first one, right? So it is printing the Ajay 1, 2, 3 because I added at the first position. When I'm going to print the last one, so how I will print? So let me do this, test it times. So when I'm going there, I will remove this get method. The data type is AL. Then we have dot. Just I put a dot and then I will call that particular method, get method. Get first. So it will give me the get first and one is get last. The other additional things I don't need. So you can see here, I will just print the first one via this, then get first, then get last. So three data I'm going to print and I will see that whether I'm going to getting the correct result or not. This will give you the first data that is correct, index this. Then this will also give you the first one. So this is also correct. And this is the last one. So let me add a couple of more things. Again, I am running. You can see here, I'm getting the last value. So get first and get last. You can see. Now, new concept. Suppose that you already have one array list or linked list. Anything you have. Either you can have array list or you have a linked list. Now you want to create one linked list. Okay. This should be the copy of that one. So what you can do, either you can like pass it via array or you can pass it via collection. So I will show you both of the way, then you will understand how to use it. You can see here. Let me comment this part. So I'm creating a linked list. Linked list of a string, linked list demo, the reference I have given, new linked list, and in the constructor I'm passing array as list. So basically I'm passing the list where I'm having like couple of things which is a collection, or either you can directly create and just pass. So this is runtime I'm creating and passing here. So one is A, BB, cat, dog, computer, mouse, whatever the value was there, I just pass it. And then I'm trying to print and I want to print this one. So this is just a show up that this is possible. You can use it like that. So let me execute this and show you that we are getting the correct output. You can see here, I'm getting the correct output. So this is one way. And second way is, suppose that I have this array list here. I want to pass it this like this. So I can also do like that. I will have linked list of what? String, string string, linked list 2 equal to new. Then linked list of what? String. Then parenthesis open and close. Just put semicolon and do one thing. Pass this as a reference. So it will create a new linked list and all the data will be same. So if you want to print, you can print and check that whether I'm getting the correct output. This is list 2. So this should be shown. Or we can check like this. AL equals list 2. So that would be also possible. First, let me show you that way. You can see here we are getting like this output. That should be okay. But if I want to check that whether this and this are equal or not, so what I will do, AL is out, AL dot equals, and then I will pass list 2. So what it will do, it will just compare and check whether both are same or not. Its contents are same or not. Okay. Now already, like we have created first AL, then we have passed AL during creation of list 2. And then in this way, it should be equals. Already we have seen the output and let me check whether it is equals. It is saying that true. True means equals. This way you can just play around the application. Now we have additional methods. This was just a concept, so I will additional methods, which is important. Add first we have seen, add last we have not seen. So let's see this example, add last. Basically what it will do, it will add to the last position. So nothing like important about this, just for demo purpose, I can show you. Add first. I'm putting it at the first position, but I'm saying that add last. Let me comment this part because it is not needed. You can see here. So we have this demo. This I'm putting at the first position, but this will appear at the last position. Why? Because this method is something showing that add last. I have not printed it. Run as Java application. Why it printed like this time I have put at the first position. So that time no data was there. So it acquired that data and after that all the data. But if I put here at the last position and then say that add to the last. So it means whatever the things were there, it will just add at the last position. So wherever you will put, it will just add at the last position. You can see here. Now I'm getting it at the last position. So not very important method, just a method they have given. You should know this. Very simple to understand. One is add all. This should you should see this add all, how to use that. This is just a simple like linked list creation. We have just seen the demo. Similar like that. You can just either create it or you can just add it like that. So consider that we have already one array list and I will create one more array list. So we have already created one more array list. And after this, what I will do, I will add this list into that first one. So how to add that? I can add this first one into the second one. That would be better. Then dot add all. You can see here add all is asking for collections. You can just pass the collection and by default position it will take from the last. But there is one add on which you can pass the index as well. So first I will show you this demo, then I will show you this demo. I'm using this one and I'm saying that I will add this one. So now we will first print the array list which we have created here. Then second I will print this one and after adding I will print again this one. Okay. Let me run this and see here. This is the output I'm getting. Just compare the output. From where it is added, it is adding from the last position. You can see here 2 times null was there. And from after that, it added the first array list into the second one. But there is a way you can control the index as well. So you have added this one. Now let me show you one more way. Let me comment this. Just again, and then comment this one. And we have add method where we can pass the index. Consider that I put here 0 and then comma. So it will start from the first position. Okay. So whatever the output you have seen last time. So it will, these values will be kept as a first, then this original values will be replaced. So let me run this. Based on index, it will add. You can see all these values are added from the 0th position. So all these values are added. And then after that, this linked list is created. You can see this is newly created linked list, but the index based position. Now again go to this one and you check anything else. Very important. I will show you outline. We have clear method. So clear method, you already know that it's very easy to understand clear method, that it will be clearing everything. So we have a linked list demo here. I have already shown you first. Then I will use a clear method and then I will show you after clearing everything is cleared or not. So this is the latest linked list. I will use dot clear. So you can see here how many clears method we have. Clear method only one. So just you don't need to pass anything. It will just clear it out. And after clearing, when I'm printing, you can see what is the output I'm getting. Run as Java application. You can see here I'm getting an empty list. So clearing means cleared everything. So this is very dangerous. You can think of that while using. Now we have additional methods. I will show you. Contains method. So contains method is just to say same like array list. Okay, so you can check whether something it is present or not. So in that context, you can use. Consider that we have one array list and I want to check whether any word is present or not. So let me check this word is present or not. Contains, you can see here, contains all, like you can check multiple data as well. One is like single data, one is collection. You can pass multiple collections part. You can check whether inside a list, a sublist is present or not, means a part of list is present or not. So let me first show you one by one. Contents, and I'm passing in the double quotes. It's a string value passing in the double quotes. So what it will do, it will check whether in this linked list, means the final one, which list is the bigger list, in which Ajay 1, 2, 3 is present or not. You can see here. So I didn't printed it, that's why it is not giving the output. Test out. Basically, you see here contains method is returning the Boolean value. So Boolean means either it will give you true or false. You have to use it in like this, print with. When I will use it, I will get the output as the true or false. One is positive test we will do, one is negative test I will do. So let me do a negative test, whether it works for negative or not. Just passing Ajay. So Ajay is not there. You can see Ajay is not there. Let me run this. It is saying that false. The contains method demo you have already seen. Now next method is important one is descending iterator is like something descending order. It is creating a new iterator and like calling. Will show you. Just let me show you the element. Get first. The element is what? I think it is kind of, let me show you element one. Let me show you first this one, then I will show you the element one. So descending iterator you already know, which like traverse in one direction. And once I am going to the descending iterator, what it is showing up as next, next, something like that. But it will something the descending order, I believe. So let me try this one because I think it's the same of iterator. Comment this out. This is not needed. So we have a final list up to here, and after that I am trying to use descending iterator. Come here, dot descending iterator, and I will create a local variable ASC iter. Just mouse over, create a local variable. You can see here. Basically, it's an iterator only, but it's a descending iterator. And how to use iterator by sprint out, you already know that, right? So for loop, we need to use while loop. Whenever iterator is there, you just use the while loop. So we have the iterator name as DESC iter, whatever the name you have given, then dot has next. This is the method you have to use condition in the while loop. And then while printing, you can use the next. Yes out. DEC iter dot next. If I'm running this, earlier the output is like that, which is printing here. And after iterator, this will print like this. Descending order, it is in that. You can see here, it is printing in the descending order. From reverse order, it is printing what? You can see here, the original value was like that, and it printed like this. If I use like this, then some space plus run as Java application. You can see here, whatever the output was there, it just reversed the output like this. So this is something reverse order printing. This is descending out iterator they have given. And basically it prints in the reverse order. So this is something new thing for you because this was not present in the array list. So now coming back, element. I will show you the demo of element. Element will return you the get first. Let me use it. Come to this linked list demo and let me comment this part. Link list demo dot element. Okay. We print it because it will print in the string format. So I will use it just for printing a shout. Basically, you have already seen it will call the first one. Inside that, it will get you get first. So get first you already know, right? So the element will just return the first element. After that, there is any impact because some methods remove as well. After printing this, just print and check whether anything is changed after using this method or not. So that's the for the safety purpose. I'm again using this. But some methods do what now? They will remove the data. We have to know which method is doing that. You can see here. So it is giving you the first element and there is no change as well. So the original content is preserved, nothing changed. So using element method is safe. You're just using the get first. So it will give you the first element. To get things we have already seen, index of. So you can get the index of any number and based on that you can use it in your class. Consider that we have some element. I don't know the index of any number like any object where it is present. So I will try to get the index of that. Ravi 333. So how to get the index of that? Dot index of what? Ravi. I'm just calling Ravi and I'm asking for the indexing. So it will give you the index number. So index number always starts from the 0. Just remember that. It is saying that 6. So what element I have passed? Ravi 33. So 0, 1, 2, 3, 5, 6. So this is the correct index number it is printing here. We are getting the output as 6. So that is the correct number. Now next method is not important. I'm just leaving it. Link last. List iterator is already here. So you have already seen in the array list. So same way it will use. So node method. Assert is element index. So it will take you the index and it will check whether true or false. What assert it is saying. Assert is element index. Let me use it because it is something new for me as well. I will use this method to check. Node method is there. I will just pass the index. South. Some positive and negative value you have to create. So let me create some of the positive values. Dot method. But it is there. NOD node, right? That is not coming. Allowed. Because I'm using here. Said that. Not accepting that. The method is already present over here. Method returns the not null node of the specified element index. We have to see this. I'll check this example, then I'll come back because I need to wrap up other things. So one is like peak and pol. So you should know this because this is important one. Peak and pol. This is like interview question. So peak and pol. You go there, it basically like returns the first and like last one, but it removes as well. You can see here. So peak, it will return you the first one, and pol is like return you the thing. Peak is what? Something like it does not remove. Peak is not removed and pol will remove here. Yeah, this is the difference you can see. Retrieve and removes, and peak will just retrieve here. So basically it fetches the value and it will just not remove. So we already have data and based on that I can show you. You can see here. Let me comment this part because this is not needed. You can see this is the final array list we have linked list we have created. And what I'm going to do, I'm going to print some value peak and fall. So let me use it as out linked list demo dot peak. So after peak, you see here first it will pick the first value and after peak again use this just to verify whether anything is changed after using peak on. Peak will not remove the value as it is saying, so it will just preserve the original things. So you can see here nothing changes. Peak is going to give you the first value, but it is not changed. But instead of peak, if you are using the poll, then what will happen? Let me comment this part and just use it and use poll instead of peak. So far in only one interview, this question has been asked to me. Otherwise, people are not asking this question too much. That what is the difference between peak and poll? So all is something, it will give you the data, but it will remove the first one. Means whatever the thing it is pointing. So let me show you that one. You can see here, it gives the first data, but it is removed as well. So after that, when I printed, after using poll, when I'm printing the original list, I can see that the value which is used by poll is gone. You can see the list is changed. So in this way, you can understand the value of peak and poll. But what is the difference between peak and poll? So this is peak first and peak last. So you can use peak first and peak last to get the first and last value. So you have already seen that get first and get last. The same thing it will then. Poll is there, poll first and poll last is there. So poll you have already seen, poll first and poll last I will show you. Let me comment this. I'm coming here, poll first. And then I'm using it and checking that whether it has gone or not. You can see here, poll first is giving you the first value, but it is removed. And then you use the poll last. Poll last will give you the last value, but after using, just check whether the last value is removed or not. You will see that last value is removed. You can see here, last value was null. And once you go there, you can see that out of two null, one null is removed. So you can use in some kind of loop iteration to perform the removal of data and printing the data. So those things you can use them. Same like peak is there and pop is there. So peak is something like a data. Pop is also removing the data. You can see here, poll is there and pop is there. So pop will also remove the data. You can see push is to insert the data. I will discuss these things in the next class because lot of things still need to be discussed. Basically, linked list is having a queue kind of thing. So whatever you are seeing the methods is not all from like what you call linked list. Other methods are coming from the queue interface. You come back and you see this map. So these all methods are coming from the queue interface. So queue from queue it is coming to a DQ and from DQ it is coming to the linked list. So that's why in the array list and linked list there are additional methods you will find out. So I will discuss this additional things tomorrow. the next class, means tomorrow's class. And then anything you have doubt, you can ask me. Any doubt you have for today's class so far?
No, Rajiv.
You go with the recording things and just try to grab the things.
Yeah.
Right. Basically, linked list is just basic things people are using. What I have seen is just for personal level. I am giving you like more depth concepts so that you can have this concept for later on. Really, it will help you. Mostly, they are not using this much. I will tell you in automation also and the development also. People are not using up to that much. Just basic operations people are using, and then you are going. Okay. Then thanks all for joining today's session. Okay.
Thank you, Rajiv.
Welcome.